Students, welcome to our V4U Chemistry channel. Here you can find Unsolved Numericals of K.L. Kapoor Volume 1. Today lecture content is dissociation constant of water and pH values. pH of a pure water is given, which is 6.765. From pH formula, which is equal to minus log of hydrogen ion concentration, we can calculate hydrogen ion concentration, which is equal to 10 raised to power minus 6.765. For pure water, water dissociate and gives equal amount of hydrogen and hydroxide ion. Now we know the amount of hydrogen and hydroxide, we can calculate dissociation constant of water, which is a multiplication of hydrogen and hydroxide ion. After using the formula, dissociation constant Kw is equal to 10 raised to power minus 6.765 multiplied by 10 raised to power minus 6.765. After solving, Kw is equal to 10 raised to power minus 13.53. pKw, which is minus log Kw. pKw value comes out to be 13.53 at 40 degrees Celsius. If hydrogen ion concentration is 1 multiplied by 10 raised to power minus 7, then we can find out pH first at 50 degrees Celsius, which is equal to minus log of 10 raised to power minus 7. Now we know the value of pH, which is 7, and pKw, which is 13.53. We can find out pOH, which is equal to pKw minus pH. After solving, pOH value is 6.53. After comparing hydrogen and hydroxide ion concentration, nature of the solution is alkaline. So final answer is pKw is 13.53 and pOH is 6.53. In the above question we have TO find out pH at room temperature, when different concentration of hydrogen ion concentration is given. In first part, hydrogen ion concentration is 1 multiplied by 10 raised to power minus 9, using the pH formula minus log of hydrogen ion concentration. We can find out pH. After calculating, pH value comes out to be 9. In part B, hydrogen ion concentration is 0.0032 molar, pH is equal to minus log of 0.0032. pH is equal to minus 1.505 plus 4. pH is 2.49. In part C, hydroxide ion concentration is 0.012 molar. First we have to find out hydrogen ion concentration, which can be find out from Kw equation. Hydrogen ion concentration comes out to be 10 raised to power minus 14 divided by 0.012. After solving for hydrogen ion, we can find out pH, using the pH formula, which is minus log of H plus. pH equation can be simplified by writing log m divided by n is equal to log m minus log n. After calculating, pH value comes out to be 12.08. Answer. Part A 9. Part B 2.49. Part C 12.08. In part A, pH is 7.63. So H plus concentration comes out to be 10 raised to power minus 7.63 using pH formula. Kw is multiplication of hydrogen and hydroxide ion concentration, given Kw at 50 degrees Celsius is 5.474 multiplied by 10 raised to power minus 14. From Kw equation we can find out hydroxide ion concentration, which is 5.474 multiplied by 10 raised to power minus 14 divided by hydrogen ion concentration. Hydrogen ion concentration is 2.34 multiplied by 10 raised to power minus 8. On solving above equation, hydroxide ion concentration is 2.34 multiplied by 10 raised to power minus 6. In part B, pH is 1.48. So H plus concentration comes out to be 10 raised to power minus 1.48 using pH formula. Given Kw at 50 degrees Celsius is 5.474 multiplied by 10 raised to power minus 14 and hydrogen ion concentration is 3.31 multiplied by 10 raised to power minus 2. On solving, hydroxide ion concentration is 1.66 multiplied by 10 raised to power minus 12. Answer part A. Hydrogen ion concentration is 2.34 multiplied by 10 raised to power minus 8 molar. Hydroxide ion concentration is 2.34 multiplied by 10 raised to power minus 6 molar. Part B. Hydrogen ion concentration is 3.31 multiplied by 10 raised to power minus 2. Hydroxidine concentration is 1.66 multiplied by 10 raised to power minus 12. In first part, we have to find out pH, given HCl concentration is 0.004 molar. pH equals to minus H plus. HCl is a strong acid, so in solution it given hydrogen plus and chloride minus. So H plus concentration in solution is 0.004 molar. pH is minus log of 0.004 molar, which can be written as minus log 4 plus 3. After solving, pH value comes out to be 2.40. Given hydrogen ion concentration is 2 multiplied by 10 raised to power minus 7. As we see, hydrogen chloride concentration is very low. So we cannot ignore hydrogen ion coming from water, as we see from the two reaction, HCl giving hydrogen and chloride ion. Water giving hydrogen and hydroxide ion. Total hydrogen ion concentration in solution is H plus from water and H plus from acid. According to charge balance reaction, total positive charge is equal to total negative charge in solution, which results in concentration of H plus is equal to sum of chloride and hydroxide ion concentration. On solving the equation, we get a quadratic equation of H plus. Solution of any quadratic equation: ax squared plus b multiply x plus c equal to 0. X equals to minus b plus minus square root of b square minus 4ac divided by 2a. A equal to 1, b equal to minus 2 multiply by 10 raised to power minus 7 and c equal to minus kw, which I c equal to 10 raised to power minus 14. On putting the values of x, a, b, c, we get hydrogen ion concentration, which is equal to 0.414 multiply 10 raised to power minus 7. Now we know the value of hydrogen ion concentration, we can calculate pH, which is equal to minus log of 0.414 plus 7. On solving, pH is equal to 6.62. Answer part A 2.40, part B 6.62. Don't forget to like, share, and subscribe, and we'll see you in the next video. That's right. If you have any questions, whether it's related to the topic of this video or any other academic subject, drop them in the comments,